Okay, we are recording.
Do you see my screen
Yeah,
or is it like blank?
it's white. Yeah, blank.
It's white now.
Yeah, it was. Uh,
Is it? Did I share
did you
anything?
share it? No, you're not sharing it.
Oh, okay. Okay, let me stop presenting the PowerPoint. That is causing the problem. Now, can you see? Can you see?
Yeah,
Hmm.
So, so we started with this slide, right? Yesterday. Why do we do load forecasting and then uh, types of different load forecast? I think there is no question on it, right?
Yeah.
And then, so I just wanted to include this to have the brief overview, right? So
Hmm.
because I'm assuming that this slide deck will be used by the new people, right? So they should at least have something. So this is already known to you, like weather history, load history, and then you do the modeling, and then you get the model out of the modeling process, and then you add the weather forecast. The extrapolating process is the model runner, right? So the extrapolating process is actually running the taking the model and also taking the forecast and then running it and outputting the forecast as CSV or any other file. So this is clear, right? Typical forecasting process is like this. So you have a modeling process and then you have a extrapolating or forecasting phase.
Hmm.
mm,
Okay. So then the next slide, uh, these slides you already have gone through yesterday. So now I just wanted to have some other things because we discussed it, right? So in our version 1 and even version 2, there are a few dummy predictors. The dummy predictors meaning that 1 0 type of binary predictor. So suppose if it is a holiday or not, right? Then you can have multiple different types of predictors. So public holiday is one of the dummy variables that you can add and you will add in your forecasting. So then another dummy variable can be suppose Olympic, right? Like if Olympic or election year, I did not include this, but I'm just giving you ideas. So suppose tourism forecasting. If you do tourism forecasting, then you must account for the uh, the uh, the I would say Olympics, right? So because there is a surge in your history during the Olympics in your tourist arrival data. So
Hmm.
in your forecasting model, you should have that uh, predictor as was it Olympic year or not, right? So sometimes you can add leap year or not. So that sort of predictors you need to add. So these dummy predictors are sometimes they really help to identify the irregular shaped load. Suppose if it is a weekend, if it is a holiday or any other special event, if you can identify, if you can give the model this dummy predictor information, then the forecast can capture this uh, that variation or that variance because of that special event, right? So always have this idea in your mind or in your forecasting skill is that always try to add any problem you are solving. It is a load forecasting, price forecasting. Like what are the special events that is happening? Maybe holiday is a special event. Then public, maybe some sort of leap year can be a special event. COVID can be a special event. Then Olympic can be a special event. Then election year can be a special event. So all sorts of event you need to think about, right? If it is important for you or not. So load forecasting, leap year or election year may not be that important, but it is just to have a good understanding of it, right? So that any forecasting problem you come forward and you can solve. So then how to include any specific dummy variable? So if you have Monday as a dummy variable, see, you have to have this kind of I would say you have to create this predictor this way. So when you have Monday, you have 1 on the Monday and 0 for every other day else, right? So then you have Tuesday, you have 1 on Tuesday and you have Wednesday on 1. So that's how you can have dummy predictors. This is This process is called one hot encoding. If you search in scikit-learn, if you tell, if you suppose you have a categorical variable in your feature, right, as a feature categorical variable, but you have to isolate this categorical variable. Suppose categorical variable can be day, so day is written in string Thursday, Monday, Sunday, but you cannot really give that feature to a random forest or XGBoost, right? So you need to isolate it. So sometimes if you give scikit-learn that this is scikit-learn one hot encoding function, you can tell this is my uh, column and this is unique values they have, then automatically it will create another couple of columns with this binary variables. So one hot encoding, you can use it. So, or you can create things manually as well by coding, right?
Hmm.
Up to you.
Mhm.
So then there are, I have also included other ideas. Suppose trading days. Sometimes trading days can be a good feature. Suppose another feature is like the number of Mondays in a month. Number of, like, if you have 31 days, sometimes there are 5 Monday, right? Which can have a little bit impact. So sometimes uh, people include it, especially during in the sales forecasting. So suppose you are forecasting monthly sales for, I don't know, maybe some soft drinks. So how many Mondays in the month can be a good predictor, right? So
Mhm.
even sometimes it can happen due to like sports season. So sports season, you can have how many Fridays that they had, right? So because sports influences a lot of other elements in the society, so that can change the ultimate time series that you are trying to forecast. So you have to know some domain thinking, you have to do some domain thinking in that as well if you need to, but I don't think you need to do it in our load forecasting case, trading days. But for other types of forecasting, it is an important metric to be able to have feature engineering, right? And then past legs, always a very good idea to add multiple past legs, right? AIL past day, AIL 1 week ago, AIL 5 week ago, whatever. That from your business understanding, if you find out that some past day is important, then you add it as a feature. So then let's go to the next slide. You have already gone through next slide. We have already covered this slide as well. We already covered that slide as well. And then, so then reliability of information. So that I did not really cover. So suppose you have a forecast, right? So if someone asks you, hey, can you give me hourly forecast for next 30 days? So you can always give somebody 30 days if you have a 30-day forecast. But is this forecast reliable? What do you think? It is not reliable, right?
Mhm.
Only reliable temperature forecast is just next day. Even 2 day after that, it becomes unreliable because the
Hmm.
weather is so much variable. So sometimes if somebody asks you give more than 2 weeks forecast, you will say that after 2 weeks that accuracy will reduce, but after 2 weeks there is no guarantee of the accuracy. So
Mhm.
always remember it. And sometimes people also use economic variable, but for short term load forecasting, we don't really use economic variable because economy changes maybe like every month, not every like hour or so. So like if you are predicting stock price, then you need to add high frequency econometric data. But for us, we do not necessarily use economics or land use. So economics and land use are really important when you're doing medium term or long term load forecasting, right? So land
Mhm.
use meaning that if your area will have lots of construction in next 10 years, then your load will increase in the area, right? So
Mhm.
you need to, so for long term load forecasting, you need to add land use data or economic and also economics data. So all forecasts have a relative accuracy, right? So weather forecast is most accurate only 1 day ahead, and it is like really unreliable 2 weeks ahead. So this is really important for you to know.
Mhm.
So sometimes, so and also another question you asked last day, right? How soon I should update my forecast or update my model? So I gave you an one answer, but I tried to look into the literature. What did they do? So depending on their requirement, right? So they have another term called VSTLF. VSTLF means very short-term load forecasting. Very short-term load forecasting, suppose wind or solar. So they update the forecast even less than in 1 hour, because they are doing like 5 minute or 10 minute ahead forecast, right? So they are within an hour they are updating the model. They are adding the new data and they're training the new data to the model, and then they are pushing the new model into the production. So it can be like every day, you can do it every day. So for us it is short term load forecasting, so you can do it every 2 weeks. In general, people suggest that you do it every 2 weeks, or you can like from 1 day to 2 weeks. This range is okay. So if your load is changing really rapidly, then you can do it every day, right? But if your load forecast is relatively accurate so far, serves your purpose, then you can delay it 2 weeks. So this is like industry practice.
So, like, one question is, why we cannot do a thing like model runner kind of thing that will train the model automatically?
Yeah, we can
Like,
do it. Definitely we can do it, but it is just adding more task on the software engineering plate, right?
okay, makes sense.
And running, like, sometimes it is a learning process. So suppose what is actually needed when they are running the model runner, right? So what is actually happening there? So suppose I have given the team the requirements.txt, the model file, and the actual model runner. So what is happening there is that at a specific instance in time, the system is initiating a server. So first the server is created, virtual server is created. Then within the virtual server, all the packages are installed, Python is installed. And then the model runner code is run on that Python server. And then the predictions are pushed into some other place for future use. So then after everything runs successfully, then the server is shut down and the server is deleted. So this takes around like 10 to 11 minutes in time, I'm assuming. Because every day, if you run every day, the forecast is actually not the forecast. The model runner will have to be run every day, right? So every day there has to be like, you have to initiate a server, then install all the packages and then shut down. So they are at this point in time, I do not know, but they are not installing a dedicated forecasting server. I do not know why, but that's the decision the software engineering teams will take. This is not our decision to make, right? So how much resource or on that engineering side, you guys have to work with the software engineers. So
So, like at this current stage, like for example, you hand over the model and the model runner to the software engineers.
yes,
So, the next 2 weeks, we will be using the same model, right?
model exactly.
But that, but
Every day the forecast is changing, right? So if you run your model runner, so if you look into the model runner code, the model runner
mm,
code is actually taking the day that the model runner is run. So it will take the date and then it will call the forecasting APIs to give the weather forecast for that day. Then it will create the input data frame, and then it will pass the data frame as a matrix to the model object, pickle object or joblib object. Then the joblib object will use the input data from the data frame and then generate the forecast.
forecast. So
So
it will not have that immediate effects on these 2 weeks, right? Like for example, in if some tsunami or like other severe thing happens in 2 weeks, the model will not be able to catch it or something like that.
I mean, if
Because
the temperature is changing, if the temperature forecast is good, then it will be able to catch some of it, but not all of it, because it do not have the, like, that if the weather feature, if the weather is out of the distribution of the training data, then how come the forecast will be accurate, right? So suppose you did not anticipate in your data frame or in your training data, suppose in the past 5 years, never ever the temperature increased beyond 30 degrees. So the model, if the weather forecast is beyond 30 degrees, then the model will use the range of the 30 degree around and it will under predict, because it has not seen that high temperature in its training data.
Hmm.
So what you need to do is, if you estimate that the next day there will be such an weather event that the past training dataset has never seen before, then you should try to retain your model even with the forecast. Then you add the forecast to the training dataset and you train the model and you deploy the model. And then if the forecast changes, the forecast changes. Then your model will
Mm.
give you a relatively accurate result. So it is it is not easy, right?
Hmm.
You have to anticipate, you have to monitor the weather forecast. I think the peak operations manager will do it. So the peak operations manager maybe give you some notification that, hey, the weather next in 7 days, there is a weather event coming. So you will take the next 7 day weather forecast and try to see it whether it is within the bounds of the training data or not, right? Did that kind of event happen during your training data? If not, then try to add this forecast into the training data and then come up with a new model and deploy the model. So that sort of capability, like the scripts are same, you just have to add the training data.
Mm.
Hmm. As
So
like actual data, right? Like the
yeah, I
forecast
mean,
that.
not the actual, the forecast. Sometimes, like if you're anticipating that the past actual data does not have that distribution of the forecast that is
Hmm.
coming, then you have to do it. Other, you have no choice, right?
No choice.
It's not.
We have to like add the forecast data to the training data, right?
Yes.
Hmm.
Yeah, it is just operational aspect of
Hmm.
doing the forecasting,
Understood.
because sometimes emergencies will occur and you have to solve it that way.
Mm.
Hmm.
So 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 just going back to the slide again, that the update of the model can happen less than 1 hour, like from. So you most of the time for short-term load forecasting for our purpose, if the system is automated, then every day you will train and deploy a new model every day if you can automate it, so that it automatically adds the new training data into the database and automatically creates a new model object, and automatically the model learner is run. So the whole process can actually be automated. Then there is no need for human intervention in some parts, right? If you have a good enough features, list of features, and good enough accuracy, the whole process can be automated.
That part we can do, like as the training we have to done, we have to do it. So why not we like uh, take that part and train automatically, write a script like the model runner, which will like take the data, train the
Yeah,
model
exactly. So just
Mhm.
each 7 day or
take
something
some
like that.
function, like one file would be enough, right? Yeah,
Mm,
you can do
Mm.
it. You can do it. It is not something unimaginably difficult. Not.
makes sense.
So you have idea, right? How to update,
Mm,
for how often you should update your model.
mm,
So then
Mm.
another topic that is relatively like common in forecasting community, they are called ex ante forecast versus ex post forecast. So if you are using forecast for forecasting, this is called ex ante forecast, which we will be doing, right? We are using weather forecast to generate a new forecast. And ex post forecast meaning that you are using historical data to forecast historical time series and then comparing it to actual. So
mhm,
usually that's what journals usually do, right? Ex post forecast. So like actually events happened like years ago. They take the historical data, and even from in the past they generate forecast and compare with the actual. But if you are doing for actual forecasting, you do not have actual data yet, because you are
mm,
actually waiting for the event to happen, right?
mhm,
So
Mm.
so sometimes people try to compare models. So always remember, is it ex post or is it ex ante, right? So people always say, hey, I have a good model, I have a very good model for 2018. Like, does it really matter? The 2018 happened years ago. how good the how good the model is performing ex ante is really important, not ex post.
mm,
Mm.
So remember it. So always, like, people sometimes cannot really, like, when people try to compare models, you always have to remember, like, am I using forecast or am I using actual data? So our model one, like model zero that I created, was actually X sorry, I think version 1 is actually ex post, right? We are using actual weather data, but now we are for version 2 we are doing ex ant. So
Mhm.
I mean, operationally, like there is really difficult to kind of distinguish between the two, but this is like a literature term in the like if some, like if you go into some forecasting domain of discussion, like people will always use these terms, ex ante forecast or ex post forecast. So I thought that you guys should know it. It is cool to at least know some terms, right?
Hmm.
Yeah.
Makes
So
sense.
okay, so then another kind of thing is that correlation is not causation. I think we discussed it yesterday a little bit. So suppose these predictors we add, right? We are adding hundreds of predictors. So does it mean that if I add a predictor, my forecasting performance improves on the validation data? Does it mean that because of that predictor, the actual event happened? Does it mean? There is no guarantee of it. So never ever feel that, never ever think that your intelligent feature is actually causing the event to happen. No, you're you are doing feature engineering or adding different features just to have a better predictive performance. There is no guarantee that because of that feature your your the event that you are trying to predict is actually happening. No, so never do it. So correlation, so never try to do it. Like you, if you are doing the causal analysis, causal, you are doing predictive modeling, not causal modeling. Causal modeling is what? Causal modeling is to identify the causes of the response. Suppose you have cancer. Does it mean that having a body weight of greater than 85 kilogram is causing cancer? So that sort of
Mm.
understanding is causal modeling. So you will also do regression modeling there, but the predictors cannot be correlated with each other, because that way it will create problem with the original response. So if the inputs are correlated, then their impact on the actual response cannot be identified or separated properly. All the all the features in that causal modeling has to be independent of each other. Suppose someone's age, then someone's birthplace, so they have no correlation. So you have no, like, you have no, you have to identify that your predictors are totally independent of each other. That way you can have a good causal modeling, and you can use it for predictive purposes as well. But there is no guarantee that causal modeling will have the accurate, most accurate result. Because if you are doing, if you take a causal model and then push it as a predictive model, it will not be the same accuracy, because predictive model is about making predictions. It is not about trying to explain something.
Yeah.
Mm.
Predictive modeling is based on correlation between the
Exactly,
predictors, right?
correlation, not
Mhm.
causation.
Hmm. Makes
If
sense.
your time series are correlated, suppose your correlation, so there is a website called, they find out like spurious correlation. Like spurious correlation meaning that two time series are correlated, but they have no idea, like they're from different domains. Suppose the daily death in, suppose in Africa, is correlated with ice cream sales in New York. If
Mm.
you make a correlation, Pearson correlation, you will find that there is a very good correlation. But does it mean that they are related? Because there is a lot of people dying in Africa, the sales in New York is increasing. Like if you plot XY, it will show that this is happening. But is it really true? So there has to be distinguishing between predictive modeling. We are doing predictive modeling, we are not doing causal modeling. So causal
Mm.
modeling is, I did some causal modeling, I think, to show that because of COVID, the sensitivity, temperature sensitivity of the load increased. That is causal modeling, right? So I take this heating degree day, cooling degree day, and make a regression model with the actual load. So that is causal modeling. So if your probability, if you're after you do the regression and you get the p-value, if the p-value of the base case, which is not COVID, is higher than the p-value of is COVID or the actual COVID case, then I can say that the sensitivity of temperature with the load has increased. because the p-value reduce, right? The more
mm,
reduce the p-value, the better your hypothesis is, right?
mhm,
This is hypothesis testing. I'm going a little bit off the rail here. Okay. So then
Hmm.
again, another case, I discussed multicollinearity and forecasting. So this is directly come from the above statement. Correlation is not causation. So you do not have to worry about multicollinearity during predictive modeling or forecasting. That's it. That's so you can add as many past regressor or past lag you want. They are correlated. I have no headache. If they are correlated, that is good.
So if any stage we want to like reduce the number of feature or like any feature selection process, then these correlation method we can't use, right? Like uh,
No, no,
so
no.
we have to use like lasso or other
Yeah,
techniques.
exactly. I think you just use
mm,
lasso, that would be fine. Lasso or feature importance in random forest or XGBoost, right? So
Hmm.
you can use feature importance for XGBoost. You get the feature importance from the modeling. If you look into the documentation of XGBoost, you will get. So that feature importance does not mean correlation. That feature importance means their impact on the predictor, or sorry,
mm,
their impact on the response, not any correlation. So do not use correlation metrics to reduce the number of features. So if you are doing causal modeling, then only you are allowed to do so. If you are doing predictive modeling, never use this correlation metrics bullshit. Like why people teach it in class, I have no idea.
Understood.
So okay, then I will show you some models. I think, suppose you do not have any idea about load forecasting, how would you start? I'm showing you some models that people have reported in literature, simple models, right?
mhm,
So if you see that this simple regression equation, so regression equation, you can do it linear regression like lasso or ridge regression or elastic net. You can use any regression algorithm if you use linear methods, or you can use machine learning or pattern recognition based regression methods. Anyway, this is the just simple equation that you can use, like beta naught plus beta 1 by trend multiplied by trend. So what is trend? Trend meaning that when the actual market started. So suppose if PGM is started to 2005, then trend value for 2005 would be 1, 2006 would be 2, 2007 would be 3. So this is a
mm,
variable that you can create, feature engineering, right? Then you can create variable day and hour and then multiply, and then you can create another variable month, and then you can have temperature, right? T. Then you can multiply them together, and then you can take the square of the temperature and multiply with the month. Then you can take cube of the temperature and multiply with the month. So this model has like shown good performance for some load forecasting applications in the past. So you can try it out, right?
mm.
Which part of these we didn't try it yet? Like we
I
already
mean,
have.
I have tried it, but it did not really give good performance. I mean,
Hmm.
not necessarily, because the temperature is directly used,
Hmm.
and sometimes you do not necessarily need this square cube features. So it so the paper that I took, they do not disclose the actual source of the data, but they show the data, and the data is actually for a small area for utility in US. So for that
Mm,
utility, they find out that this I think you can use it as a zonal model. Try it out during the
mm,
PGM zonal model. You can try this out. So you have to create your input data shape, data frame by this, and then just do the regression, right? So another improved version is like this. So now they use the past feature t minus 1, right?
mhm,
Load. So why is the load actually, like why they write why, I have no idea. They could have just wrote load, and they take the same approach of the past. They just add this load t minus 1 past value,
Previous hour. Yeah.
previous hour.
mm,
Hmm.
So this is another model you can use. So then another model is like the next is the better model. They use lots of temperature and temperature shift t minus 1, t minus 2, t minus 3, and they also use average of temperature, TW. They create this TWT, which is kind of same as average, but they call it weighted average. So I did not really explore it because it is very difficult to deploy. If you do not have a dedicated server, you cannot really deploy this model. So because the model will need the historical data at all times for prediction. Suppose you are doing a average, rolling average, right? So for rolling average, how can you create the rolling average if your model runner does not have access to all the latest rolling average data from a database or
Mm.
API?
Hmm.
Did you understand it? I think it is a little bit difficult for you to understand, right?
Mhm. Mm.
Yeah, understand a little bit. Like, yeah, like we are just, for example, and currently we are just for forecasting, we are just taking the next 24 hours data, right, and
Hmm.
making the features
Yeah.
for as an input to the model.
Hmm.
But if we would use this moving average, then we might need also the
The
previous
past data,
historical
previous
data,
data,
past
correct.
data, which can be done, but it's complex, and we might have to we might need two APIs, one for
Yeah,
forecast
it,
temperature,
that's
one
why.
for
Exactly.
Mm.
historical temperature, right? So
Yeah,
that's
that's why I did not do it because it will just make the deployment much difficult.
hmm.
Mm.
So you can use some of the features, right? You can use most of the features, or you can take a daily average because, but it will be like same for all 24 hours for every day.
Hmm.
Mm.
Yeah.
But here they take the rolling average, right? Rolling average meaning that you need to have, like, you will just sliding, right? Sliding mean. But the problem is that if you do not have past days data, then how you can take the rolling average? That's the issue. Not past day, because the rolling average is actually taking the impact of past in the future, right? So this is really difficult. So, but you can always use t minus 3, t minus 4, t minus 5, right? This feature. So
Hmm.
this is another model you can try. So I'm just making things as easy as possible for someone in Empowered. Like if someone sees this presentation, they should be able to start writing code immediately, because you know the how to create a structure of data, right? Then ultimately the regression problem you are solving. So how difficult it is? You just need to know the features,
Mm.
Hmm.
and I'm showing you how to come up with features. And then cross validation, I think Habib already knows it, right? Use cross validation.
Oh,
I'm
one
just
more question
Mhm.
is like, in the feature we have previous hour AIL and also like last week AIL, right?
yes.
So that
You can
feat
use you can use uh
oh, like for the
yeah,
energy we are getting it
energy
from
stream.
energy stream, so that's not a problem. Yes. So
Mm.
mm, I- yeah, that's it.
Hmm.
Tree and forecast.
Okay, so time series cross validation, I think Habib, you already know it. I'm just putting it here because for the sake of completeness, right?
Mm-hmm.
Mhm.
So because forecasting is actually always about future, so you have to split your training testing data during cross validation in that way. You cannot just make random splits and like go over the data set as you like. You cannot go back. For forecasting, you always have to look forward. So you have to start splitting the data going forward in time, not backward or randomly moving backward and
Mhm.
forward. You cannot do it. So suppose here they created almost like 20 different models with increasing data set, right? Distributed the data set into increasing order. So you can do it, or sometimes I've seen people just omit the past data and they like move, like they have all the data set, not necessarily increasing order, they have all the data set same, but they just snap it from different parts of the time series. That is
Mm.
another way I've seen people do it. But what does it matter, right?
Mm.
I think, or then in that case, all the model will have kind of same accuracy, which is not the goal we need. We need increasing accuracy.
Mm. Yeah, sense.
So lucky for us, scikit-learn already does it, so we don't have to worry about it.
Yeah, it will be really difficult to
It will be really
code
difficult.
it.
Yeah. Okay. So then this is how you select a model. So suppose you have three algorithms, but you have to come up with three different models for that three algorithm, right? So for every algorithm, you have to do the same process accordingly. So
Mm.
you take the database and then you make a training data set and a validation or holdout data set. Then you do not touch the holdout data set, just keep it in somewhere. And then you run your time series cross validation and hyperparameter optimization with the training data set, right? And then you come up with optimal set of hyperparameter, and then you train the model with the selected list of hyperparameter on the training data.
Mm.
And then you forecast the testing period on the testing period, and then you compare it with the testing data and you save the result, and then you do it for all the algorithms. So moving forward, you will have maybe lasso, you will have cat boost, you will have XGBoost, you will have deep learning, all these algorithms. And then how you compare all these algorithms in this method, you run it for every one of it, every one of these algorithms, and you save the mean absolute error, and then you compare it on test data, and the lowest mean absolute error wins, right?
Mm-hmm.
Mm.
So this is really important for you to understand, right?
Yep. Sense.
And then finally, after you selected the algorithm, say yes, XGBoost, I want to add XGBoost. Then you just train that XGBoost with hyperparameter on whole dataset, all training, validation, everything included. And then you just deploy, then you just output a joblib file, and then you give the file to the software engineers. That's it, right? With the
Mm.
model runner, of course.
What is 200 here?
2000, like 2005,
Oh,
6.
okay, okay, okay.
Mm.
Sorry. Mm.
That's why I put X, right? I mean,
Mm.
I'm assuming that you will not need 1999 data, so that's why. I mean, if you have monthly, if you have long-term load forecast, you will need. If you're running load forecast for next 20 years or 50 years, then you need 1940 data, even
Mm.
to capture the actual trend, right?
Mm-hmm.
Because for short-term modeling, you don't need to worry about the trend, because you're very short term. You're only looking one day ahead. How much is it?
Mm.
Then finally, this picture you already know. So okay, I will stop sharing and I will share a new page. Okay, so anything on the, I think I have covered forecasting really well. What do you guys think?
Yeah, I think
Yeah.
so.
Mm-hmm. It's kind of like a step-by-step process. Pretty. Mm-hmm.
Yeah,
Yep.
from feature engineering to modeling,
Mm-hmm.
dep yeah, more deployment. Yeah, pretty much all.
Okay, so then I go to the uh, I think I will go over our folder as well. So what is in our data science folder, right? Do you see my screen?
Yeah.
Yes.
So the task plan, I added some comments on the task plan. Do you guys see it? If you open it, is all.
Yes.
So I would say that after we have this session, you go over and add your own comments. So I have add my comments and you also add your comments, right? But you did not add comments on all points. So if you can do it,
Mhm.
that would be really helpful. So I have, so just read it, and after the meeting we can, you can add your thoughts on that specific. So I added my thoughts to most of the cases. Okay. So just to have you, because our this data science folder has been grown for last 2 years, right?
Mhm.
And we have lots of things. Did you had a chance to look into everything in here? So there are lots of things in our folders: energy market basics, Frank's exit interview, timeline. Maybe you guys would add my exit interview. I don't know whether I would have it or not, but yeah. So
We have a
forecast.
folder called Fahad's knowledge transfer. I think that's
Yeah.
pretty much it.
Okay. So, but you should look into lots of things. So energy streams demo, then energy streams data, some presentations that we used to do, utility demand and potential. So I uploaded some random data sets that I found in the internet one day, thinking that it might be helpful for us. So look into it. Look into different folders. You will find hidden knowledge, because sometimes just I had ideas and I put it in the folders.
Mm.
About energy stream, like when someone uses like energy stream software, and that time can we use in API calling too?
Yeah,
Like,
exactly. API has no issue. API, you cannot just
We
use
can.
desktop.
hmm,
API has no issue. API is separate,
oh,
because I mean, although both the desktop client and the API are talking to the same databases, but what I think is that like they control the desktop accessibility, but they do not control the API accessibility.
Mm.
makes sense. And uh, for weather data from WWO sources,
Yep.
so we don't have a premium account yet, right? Like
Yeah,
still we
you.
are.
Yeah, exactly. You can set up a premium account. I don't think it will cost you that much.
Hmm.
Mm.
Why not you like set up a date moving forward with
Hmm.
WWO, and add Mike and Eugene in the meeting, have a chat with their salespeople, and finalize the
Sure.
contract.
Sure.
Sure, yeah.
So state energy policy. So yeah, I mean, I had a lot of document put up in some point in time, so you can use it,
Mm.
right?
Sure.
Yep.
Okay. So, and the markets, I think you guys know better than me here. So we did a lot of other tasks as well. I think Eugene was asking about Montana. Did you
Yeah.
did you see it? We had Manitoba, New Brunswick, and Denmark. I did some study on Denmark
Yeah. Exactly.
at one point in time. And then Mexico, we did a lot of study on Mexico. Then I also did some study on Hydro Quebec. So there were a lot of study in the past. So look into it. Okay.
Hmm.
Hmm.
Who is Hydro-Quebec regulated?
Yeah, it is regulated, and they just have a demand response program.
Okay.
And for industrial customers, I think they pay about $50,000 a year for one
Oh.
month.
Okay.
But like they call you, right? Like they give you notice like maybe 2 hours before, and you have to respond. If
Yeah.
you don't get the money if you do not respond.
Mm.
Hmm.
There is similar program in Saskatchewan as well.
So there
Mm.
is no peak related program, coincident peak
No,
something.
only demand response, and it is run by utility. I think about it. Like if the electricity market is running demand response program, it's really weird, to be honest with you. Like PJM should not be concerned about demand response. It is demand side responsibility, right? Thinking about it.
Mm.
PJM should only focus on running the markets, but they have all sorts of programs, this program, that program, blah, 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 like so many programs.
Mm.
And the utilities are not doing anything. Utilities, most of the time, they have very few programs, except for maybe New York or ISO/NE or California. Like Texas utilities, they're not doing much.
And then they screw up.
I mean, they screw up not because of them, to be honest with you, because
Yeah.
the generators did not work during cold. And
It's not even that cold.
yeah, I think, to be honest with you, the forecaster has a lot of responsibility to take. Weather forecasting has a lot of responsibility to take, and I think they did the weather forecasting, but they did not happen that it would cause this much commotion or this much problem.
Mm-hmm.
And they don't have a capacity market, right? So
Hmm.
their generators are not up to date. They are not tested properly.
Mm-hmm.
So
There are many times that they have like the price spikes, energy price spikes. I mean, like $9,000 per megawatt
yeah,
hour.
$9,000 lasted for almost, I have seen it, almost 4 days.
Yeah, exactly.
$9,000
Those are
flat.
crazy.
Really crazy.
Yeah, okay.
Is BC also deregulated or regulated?
Deregulated. Sorry, regulated. They have BC Hydro and Fortis BC. So they kind of like, the BC Hydro is the biggest one, and they don't have any electricity market, but they're connected to Oregon. They have interconnection
Oh.
with US. So they have power transfer between US and Canada,
Mm-hmm.
and I think they also have connected to Calgary. They're also connected in Calgary as well, but
Yeah,
they
they
don't
have
have
some
an
connection
electricity
to
market.
Alberta.
Yeah,
Mm-hmm.
but they don't have a market like ISO or ASO.
Okay.
Hmm. Makes sense.
New Brunswick had a market, but I think they shut it down in 2011.
And what
2011.
is the replacement for that?
They just from regulated they become deregulated and then they become regulated again.
Oh, okay.
Weird.
Sometimes the province cannot, like
Utility
the
shut it
province,
down, I guess.
yeah, if the province is not like willing to respond to this dynamics of electricity market, then it is better not to have electricity market in the first place,
Mm.
Hmm.
because not all people can understand this, right? So in a small place like New Brunswick, where how does it even matter? British Columbia should have electricity market. That's what I can say.
Hmm.
Yeah.
Hydro, like Quebec should have electricity market, but Quebec sells a lot of electricity to New York. They have lots of interconnection, but
Mm.
they don't have electricity market by themselves. Okay, so look into it before I go. Like, look into the different folders. If you need some explanation of what is going on in that folder, I can give you. Okay.
Mhm.
Otherwise, you have to call me again maybe 1 month later, and I forget. Yeah. Okay, so I will
Mhm.
end the presentation, but I will show you the version 2 code that I uploaded just before we hung up. So do you see the structure of the folder now? I have included everything. So
Mm.
I think there is some question or comment on the task plan about different versions. So I have written it, like I have read, like, you suppose you go into V2 dataset, right? You will see version 2 data, like that actual training dataset that I used for version 2 model. So this is
Mm.
here. So for the version 1 dataset, I think that I gave Habib to do the hyperparameter tuning, right?
Hmm.
This is
What's
here.
Mhm.
the difference between the two?
So the main difference is that I used 2019 and 2020 training data to forecast 2021 training data for version 2. Whether in the past I used from 2015, right? So if you just open the files, you
Mm-hmm.
will immediately recognize. So I did not really put down what is the actual difference, but I made some
In
comment. I made
okay.
some comments here.
Hmm.
Mm.
What is the actual difference between V1 and V2 model wise, not the training data wise?
In terms of training data, the features are same, just
No, the
the
features are also different, right? But
It's
okay.
I have
reduced, right?
reduced number of features. So okay, let's go to the V2 model folder. So you have your training data again here.
Mm-hmm.
Again, I have put it because if you just copy the folder and then you start automatically want to start coding, it is better to have it in a same folder, right? So
Mm-hmm.
then the model file, joblib file that I generated, and then modeling. So modeling, and before that, training data creation, like how did I create the training data in the first place? I think that's what Habib asked about yesterday, right? Like how did I create the training data? So if you look into this script, that's how I created training data.
Mhm.
So it is same as almost
So
the
in the
version.
version 2 of the model, the version 2 model, you don't have, you didn't take 15, 16, and 17 and 18 data, only
No,
19
if
and
you look
20.
into it, 19 and 2021. So I
Mm.
used I took the latest last 2 years plus worth of data.
Mm.
Because why? The for If you look into I'm using the weather data from energy stream, and weather data forecast streams are only available up to May 2019. So if I want to train a model using forecast, not actual, I have to limit myself into 2019 year. But it is still had actual data for 2019 January to uh, January to May. Sorry, January to April. Because from May the forecast is available. So,
Mm.
so it is 2021 February, right? So the time series of forecast they have available for 2019 May.
And we cannot request like any further.
I did not do it. You can do it, of course.
So
So
they
Okay.
just, they have immediate 2 years forecast, something like that,
yes, exactly.
and they have it for every other
I think
only for
only for
Alberta, or
Canada. Only for Canada I have tested. So you can, if
uh,
you want to look into,
so
because they have
for
weather data for other parts of the North America, right? You can check it. If you just if you just make an API call for that stream, maybe just give it 2015 and see if the data is available or not.
so when you so your hyperparameter and everything are same here in version 1.
No, no. So this is just the data creation script, right? I
Hmm.
just added different features, right?
Hmm.
And you see that I added the only Calgary and Edmonton. I removed other locations as well because those are really not adding any value.
Hmm.
How do I come up with that? Because my plan was to add lagged temperature features. So I am using T minus up to T minus 24
Hmm.
for every location. So if I use like 7 locations, it will create 7 multiplied by 24 features. It will be too much. So that's why I only kept myself from I only kept myself within Calgary and Edmonton. So if you have come here, so now I'm into the modeling script, right?
Hmm.
The actual model development script. So you have the training data here, and then I also added a feature called COVID here. Do you see it?
Hmm.
Hmm.
So for COVID, like I only tell the data set that only 2020 year from February to December is the COVID months, not 2021, not 2019, not even 2020 January, only February 2020 to December 2020. I have added a feature called is COVID, which is 0 if there is, if the value is outside the range of the COVID period, and 1 for the within period. So you can create, this is just another feature that I added
Mm.
before before I do the modeling, before, because the is COVID feature is not available in the dataset. It is just created while I was doing the modeling, right?
Hmm. So from February to December, right?
Yes. Look at
Hmm.
it. Look at here.
Hmm.
Right?
Hmm.
So that way you can create your own features. So it's all about feature engineering, right? As I mentioned always, it's all about features. And then I created this lag feature. Look at this.
Hmm.
Mm.
Right.
So now it is the final list of features. Do you see? It is not that much.
Hmm.
Yeah, if you include like a couple more stations, then it's gonna be like at least 48 more.
Yeah, exactly. So
And
that's why,
and
like,
in comparison, the training data are less. So
Yeah, so that's why I did not really add that much features, right?
Mm.
So then you do your hyperparameter tuning here. I think same.
Mm-hmm.
So I use max depth, gamma, reg lambda, alpha, call sample by tree, estimator. So I played with the different ranges. So different than the version one. Not so the ranges of hyperparameters are not the same as version one. They are a little bit changed.
Mm.
So I just use the mean absolute negative mean absolute error, because mean absolute error, like the I use the cross val score function. I think Habib did not use it during his in that in his code, but I use it. But the main problem with this cross val score function, even though it makes the code compact, but the main issue is that it maximizes the error function. So you have to negate the loss function to make it like minimize, because if you're maximizing a positive thing, then it is same as minimizing the negative value, right? So that's why you have to write scoring equal to next. So after you do it, like only one line of code, that is really saving me a lot of time. So then you just I printed out all the loss functions, as you see, and I also printed the variance. So this is 290 minimum absolute error. So 290 megawatt average loss, the error, right? So it is really difficult to reduce. So let's see how minimum I could got. I could got up to 238. So even after lots of time of hyperparameter tuning, right? So it is really hard to reduce it. So that's why you need augmentation, error augmentation. And you just then everything is as previously. So you just create your final model like this, right? You train overall every all through your training data set, training plus validation, and then you just upload, you just output a joblib file. So somehow I kept this mean absolute error here. You can change it. It doesn't really matter, right? Like at this point in time, I am not really interested in taking any more errors. I'm just interested in outputting the model in a joblib format. If you just comment it out, it's fine. So this is the modeling script. I will upload the train model, model runner script shortly. So I want to also want to open this file for you, because I gave this script to gave this file to Habib, right, to make the error analysis.
Yeah, yeah.
So I did some filtering. So I just make a pivot table here, and do you see, this is the hour, every hour of the day error, and this is for year 19, year 20, year 21. So what is the hour, what is the average hour, sorry, average error? So if you look into it, if you look in this file, so this is the error, right? So this error, and I just disaggregated in this pivot table for every month here, 12 months, and for every year in the training data set, like 19, 20, 21, 19, 20, 21, 19, 20, 21. Because they do not have March data. So that's why you do not have 21 here, right?
But
And then
19 and 20 are the
2019.
are, are those they are they were in the training set, right? Like
Yes.
so you tested the model on the training set here to test.
Yeah, but now the prediction is across 19, 20, 21. Now after I pick the hyperparameter and everything, I have I have trained the model with the same hyperparameter across. I have fit the model across the all data set, and then predicted the prediction, and then use the prediction versus actual for this error analysis. Is it confusing?
Uh,
I have shown you. That's why I gave you the picture, right?
no, not confusing. Just one thing that uh, so the version 2 model is trained on 19 and 20
Yeah.
and tested on 21, right?
Yes.
So so from where these 19 and 20 test performance are coming? That's the question.
No, 19 and 20 test performance is not coming. It is not test data. It is ultimate prediction fit data. So I have tested. I have done the hyperparameter optimization.
Hmm.
Done. So
Done.
after you done the hyperparameter
Hmm.
optimization, and then you have the optimal set of hyperparameters, and then
Hmm.
you declare a model with that hyperparameter, and then you
Hmm.
fit the overall data set with that hyperparameter, and then you generate the prediction. Model dot fit with X train, model dot fit, model dot predict with X train again.
Hmm. But isn't it like your model is already trained on those data? So if you predict on the same data, it is it not biased or something like that? Like I'm just asking.
Yeah, that's why you have 19, 20, 21, all 3 years, right? So that's why you have all 3 years disaggregated so that you can see. So if the model is trained on 19 and 21, sorry, if the model is trained on 19 and 21, it will have, of course, it will have seen that data. So
Hmm,
that's
hmm, hmm.
why they have that this error. I'm just trying to see everything here.
Okay,
So
yeah, so understood.
right,
Just comparison, yeah.
just comparison here. So suppose
Hmm.
if the 21 data the model has not seen, so I'm trying to
Hmm.
see what is the error in 2021, because I know that this error the model has already seen.
Already seen.
What is
Hmm.
this error?
Hmm, hmm.
So that's why. So
Understood,
now,
yes.
yes. So now you can just add this with all the forecasting. If it is like because it is the average value, it is not actually that accurate, right? Because I did not do the distributional analysis, but it is semi-accurate. Even if you add this error on the actual forecast, it will give you more reliable forecast. I mean, relatively reliable. The adjustment of the forecast, you have to use this error, right? For coming up with the adjustment formula.
Hmm, hmm, hmm.
So, I mean, adjustment formula not on top of the ensemble or meta model. Meta model is separate. I'm
Hmm.
just asking, if you do not do any meta model, how you adjust your real time forecast? Sorry, how you adjust your forecast with the error.
Hmm. Yeah, makes
And
sense.
so negative means the more red, the more negative error, and the more blue, the more positive error. So if you just look at it, you can understand like which hour has positive error and which hour have negative error. If you just color distinguish it by color, you can do it by conditional formatting. Have you used conditional formatting before?
No, I didn't.
So, yeah, I mean in Excel it is really where is the conditional formatting? I
Maybe
did not
format
do it here. I did it in,
Excel, right?
yes,
Hmm.
this one, conditional formatting. So conditional formatting will help you identify, like visually identify different numbers, right?
Hmm. Makes sense. So
So
normally in version 2, like using the temperature forecasts instead of actual temperature really help, right?
real helped, it
Yeah.
helped.
So if we can get those data from WWO, we can request them for that. Then it
Exactly.
will be
So
like
always
game
try to
changer,
keep that.
something like that.
Yes, yes.
Mm.
Hmm.
I would not say
That's
that model one is bad. Model one is just, I would say that it is just overfitting during the peak hour. But in general, although it like almost 100 megawatt shifted, right? If you just add 100 megawatt on top of it, it would be fine. Like it would give you a believable forecast.
hmm. Yeah, like if we do a error analysis like that and add those adjustments, then it might
Right, yeah,
perform good. Yeah.
that's why I told you, like you can do it this way. You can generate this pivot table sort of way and think about it. You can
Hmm.
automatically get the average error and you just add it. If you want to keep it things simple, but if you want to do the distribution analysis, you can do it, right? You
Hmm.
can take this as a pandas data frame and then disaggregate the error according to the hour, and then just fit a I would say kernel density function.
Hmm.
Have you seen or worked with kernel density function before?
Not really. It just a curve fitting, right? Like
Exactly. It's a
curve fitting.
distribution fitting, not curve fitting.
Hmm.
I will show you here.
Distribution.
Do you see it? So see, so this is your like data, right? After you plot a histogram, your data looks like this. But then if you fit a kernel density estimation, then if you fit Gaussian kernel density, it will be a smooth probability distribution, and you can sample the median, mean, whatever from that distribution. Or you can just you can fit a normal distribution anyway, right? But the normal distribution may not be accurate. It may not be representative of your actual sample. It will give you a best fit normal curve, but the mean or median might not be representative of the actual distribution of the error that is coming at that hour. So then this is best way to keep it dynamic. So how to keep it dynamic? You use kernel density estimation method with Gaussian kernels. It will give you a smooth distribution, and then you can sample the number from that distribution. So what is the most probable number from that distribution, right? It will give you mean or median.
So like so we
So
need
look at it.
every for every hour how much is the error, right? This distribution, right?
Exactly. Yes.
Mhm.
Yes.
Like the
So
histogram, it was.
this x-axis would become the error.
So it will have 24 histogram, right?
Yes, 24 histogram, and then on top of that histogram, you will fit a Gaussian kernel, 24 different Gaussian kernel.
Understood.
So the main hyperparameter here is the bandwidth. So you have to play with the bandwidth. You can do I would say you just do a grid search for the bandwidth, and then it will remain less than 0.5. I can tell you. I worked with this kind of kernel density estimation before, usually very small. This bandwidth, if you'll write kernel equal to Gaussian, and bandwidth will become your hyperparameter.
If we know like the hourly hourly distribution, hourly for each of the hour we have a distribution, right?
Yes, exactly.
Makes sense. It's a
Because
complex
your
thing actually.
error is different in different hours, as you can see. So if the error are similar, suppose minus within a range from, like, if some hour you are more accurate, some hour you are less accurate. So that gives you indication that the distribution of different hours are different.
So like in the error analysis last time, I shared with you a plot, right? Like for each of the hour, how much is the mean absolute error?
Yeah.
So that was kind of
That was
similar thing.
assuming you have a that was assuming you have a normal distribution of the error, but it is not true, right? Because that statistic assumed, inherent assumption is you have a normal probability distribution.
Makes sense now. Yeah.
So usually it is a skewed. Usually in the demand forecasting, not necessarily load forecasting. In demand forecasting, I have seen they are positive skewed distribution. Most the error are positively skewed. So you have a skewness of maybe some. They have a skewness parameter. So you can use maybe gamma distribution to fit it if you don't want to use kernel density estimation. So I learned these topics in my stat course. Like it was like all about fitting distribution to the data. I mean, the different, like, you fit regression parameters, right? You estimate regression parameters. That is one kind of fitting. But in like statisticians, they don't really care about your model. They care about the distribution most. So first, They create a distribution from the sample, then they generate a population, and then they use the population parameter for further inference.
So by kernel density estimation, we are making populations
Exactly. You are generating
for
a population, and
to
then if the
get more
sample
samples.
maybe yes, exactly. Then you can create hundreds of samples from that site. So kernel density estimation is a very popular technique to create synthetic data. Suppose you do not have enough data in your data set, so you can fit a kernel density estimation for each feature, and then you add synthetic data in your data set to make a big data set out of a small data set. So if you have a weak data set, that's how you can use kernel density estimation to create a strong data set or a large data set. These are like entirely different area of machine learning, synthetic data generation. That happened because when when you want to have a like a electric vehicle prediction, right? Like because very few people will have buy electric vehicle, maybe out of like less than 0.2%. So if you want to detect a electric vehicle classification model out of a population, the dataset is heavily imbalanced, right? So then you use the existing sample to create a population. Then you can use the KDE method, this kernel density estimation method, to create new training data. And then you add or blend it with the existing training data and make a large dataset, and then you create the predictive model.
Makes sense. So like, for example, if we can generate this type of density plot, then we can adjust our prediction with each of the hours error, right? For
Exactly.
example, if it is 0th hour,
I think you can
we
just
can
if you spend 2 hours tonight, you can generate it because the code is basically in front of you.
yeah, and already we have all the data, right?
All
So
the data. Yeah. So if you can do it, that is fine. Like I can help you. Even I mean, I will check because I had some cross validation codes, but you do not need cross validation. You just make a list of bandwidths, and then you make a for loop, and then select the optimal KDE bandwidth. But usually, if you keep it 0.2, 0.3 is fine for simplicity. Bandwidth meaning how sharp your distribution will be. If you have a less bandwidth, it will become fat. If you have a high bandwidth, it will become sharp.
sharp meaning more accurate, right?
More
Like
accurate.
more
Yeah,
fit,
it will
more
like
going to
overfit. It will overfit the data then.
yeah, overfit the data. Understood. And we need that here. We want that
Yeah, that's up to
in
you.
this
So you can
case.
have a bandwidth maybe one, and then it will basically just fitting everything in your training data set. That's it. But usually, like you want to have a wiggle room. Like you have like no distribution is ever like that sharp, right? So you still keep a little bit fatness in everywhere. So just make it more realistic.
Yeah, that's a good concept. Really appreciate.
Yeah, no, I mean, this maybe help you going forward because sometimes you will in come across a machine learning use case which have a very small data set. So how do you approach it? If you make sure that your features are independent, then you can use KDE method to generate more features because every feature is independent, right? So every feature will have a distribution, separate distribution. So then separate distribution you can generate like hundreds of thousands of samples, then you can have a very good balanced classification or regression model. So this is a very common technique, by the way, in power system, because in power system there is very less amount of data. So most of the time you have to generate synthetic data.
Makes sense.
Suppose this Texas extreme weather event, right? So if you do not know the distribution, because maybe there is one or maybe over 50 years there may be 5 events. So you have to generate synthetic extreme events to make a good classification model, right?
Yeah.
So you can also use bootstrapping. They like if you do not want to use KDE, there is another method called bootstrapping. Bootstrapping meaning that you make sampling with replacement. So you can search it. I don't want to explain it. So there are other techniques, the bootstrapping, kernel density estimation. Kernel density estimation is very fancy, so why not use it?
Makes sense. Awesome.
Okay, so I will stop sharing today's session. I hope you learned something,
Yeah, for sure.
Definitely.
and I will show you the model runner part tomorrow at the ending session. Okay.
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 So
All right.
I'm stopping the recording now.